As molecular-level electronic, photonic, and biological devices grow smaller, approaching the nanometer scale, chemists, physicists, and materials scientists strive to predict the magnitude of the fundamental intermolecular interactions, and whether new hierarchical combinations of these material components will assemble and function as designed. Scientists at Case Western Reserve University and collaborators at University of Massachusetts Amherst and University of Missouri Kansas City unveil Gecko Hammaker, an open-source computational and modeling tool with a full-spectral optical web service, highlighted on the cover of today's issue of the American Chemical Society's journal Langmuir. Researchers can use the software to calculate van der Waals forces between molecules and meso/nanoscale units, predict molecular organization and evaluate whether new combinations of materials will stick together, thereby facilitating the design of meso/nanoscale self-assembly. We open a whole range of insights into deep physics and share it with the scientists who are working on new self-assembled materials, said Roger H. French, the F. Alex Nason Professor of Materials Science and Engineering and Faculty Director of the Applied Data Science minor at Case Western Reserve. The free distribution of the Gecko Hammaker source code and its optical spectra open data has great utility for design and fabrication of new mesoscale systems.